Okay, last video, the second part of section 13G in our textbook. Uh, this example 15, the second part of it said, show that lines 1 and 3 are skew. So remember, skew means they are in a 3D space and they never intersect. So in order to show that they're skew, we actually have to show two things. We have to show that they don't intersect, and we also have to show that they're not parallel. Okay, so to show that they do not intersect, we're going to try to find that point of intersection. Okay, so we'll do the same procedure we did before, finding that point of intersection. Okay, so finding that point of intersection means we're going to equate the x components, so -1 plus 2s is equal to 1 plus 2u. Equate the y components, 1 minus 2s equals -1 subtract u. And equate the z components, 1 plus 4s equals 4 plus 3u. Okay, again, we only have two unknowns, so we only need two equations to solve them. I'll choose the first two and I'll rearrange to make it easier. So 2s subtract 2u is equal to 2. And rearranging this one, -2s plus u is equal to -2. Okay, now I can do elimination right away by adding these two equations together. I'll eliminate the s. So adding them, I have -u equals 0, so u equals 0. Okay, so if u equals 0, okay, I could substitute that u in here now into line 3 to find where that point of intersection might be. And remember, to check that, see that I'm correct, I would go back and then find what s is equal to as well. So let's substitute u in here for 0. 2s subtract 2 times 0 equals 2. So 2s equals 2, s equals 1. Okay, so now we know that u is 0, s equals 1. If I went ahead and found that point of intersection here, I actually know what's going to happen ahead of time, but I normally wouldn't. But I'm going to end up with a different answer than if I went here, a different answer. So instead of doing both of those things, a quick check to see, since we were showing that they're skew anyway, we could say, okay, I'm going to use u and s, and I'm going to substitute u and s into this third equation that I had to see if it is true. So s is 1, and u is 0, and 5 equals 4. Well, no, we know that's not true. Okay, so therefore they do not intersect. And if I tried to find that point of intersection, I would get a different answer for the point of intersection for line 3 and a different answer for line 1 by substituting u for 0 and s for 1 in. Okay, so I've done the first part. I've shown that they don't intersect. Now we need to show that they're not parallel. Now remember, parallel lines, if we look at the direction vectors, then parallel lines should be, or will be, scalar multiples. The direction vector of one will be a scalar multiple of the direction vector of another. Okay, so let's take a look at the direction vectors. So line 1 direction vector, so b1 is 2, -2, 4. Okay, line 2 has a direction vector of -1, 1, -2. And oh, I'm not dealing with line 2 though, I'm dealing with line 3. Okay, never mind. The question was talking about line 3. Okay, we can see that those would have been. Line 3 is 2, -1, 3. Okay, so we can see that b1 is not a scalar multiple of b3. Okay, because right away the x component is both 2, which means that k would be 1, but nothing else will work there. Okay, so we've shown this, therefore not parallel. Okay, so no intersection, not parallel, therefore these lines are skew. And remember, skew means they are in a 3D space, but the lines will never intersect. Thank you. Have fun with it, guys.